Hi everybody. In this presentation, I'll be talking about categorical data analysis, and in upcoming presentations, I'll be talking about non-parametric procedures. So I will start with categorical data analysis. In order to start with this, I will introduce the concept of contingency table. What is a contingency table? It's simply a two-way table that is used to determine whether two directions of classifications, like two qualitative variables, are dependent. As a result, we have a test of hypothesis where our H1 or alternative hypothesis is to test and see if two directions are dependent, whereas our H null is trying to see if two directions are independent. So pay attention that we want to test the dependency, and that is what we put in our H1 or alternative hypothesis. So let's look at one example together. 3 pension plans have been selected by 500 employees. The company wants to know if the selection of pension plan differs depending on job classification. So as you can see in this company, they have two types of jobs or two types of contracts, salaried versus hourly jobs, and they have also three types of pension plan 1, 2, and 3. So they have give some questionnaires to their employee, and they want to know how many of each of these job people in each job classification have chosen any of these pension plans. As you can see in this table, 160 of people who are salaried, they have chosen pension plan 1, 140 of those have chosen pension plan 2, and 40 of these salaried workers, they have chosen pension plan 3. The same data have been collected for hourly workers. It means that 40 of hourly workers have chosen pension plan 1. 60 of people who are hourly workers have chosen pension plan 2. And again, remaining 60 have chosen pension plan 3. The summation of all the data that we have in this table is equal to 500, which is the summation of total number of employees or total number of observations. So this is a very general contingency table format. So as you can see, really I have a R by C matrix. It means that I have R rows over here and C columns over here. If I want to make a connection between this matrix and the problem that we just solved, C is the pension plans. So as a result, C was equal to 3 in the previous example. And R was type of jobs that we have or types of contracts, which was equal to 2 because I have only two types of jobs, salaried and hourly workers. The numbers that we see in each cell, for example, N22 is the number of people who are in row 2, column 2. N2C is the number of people who are in row 2, column C, or second class of direction 1 and class C of direction 2. Also, we need to calculate the summation of rows and columns. So as you can see, N1 dot over here is representing the summation of all the values in your row 1. N2 dot is the summation of all the values in row 2 for all the columns, which is shown over here. The same thing is true for columns. When I want to calculate the summation of columns, for example, summation of all the values in my column 1 is shown with n dot 1. The summation of all the values in my column C is shown with n dot C. The summation of all the numbers in the matrix n11, n12, all the way to nRC is n, which is the total number of observations. So we wanted to run a test. What was our test? I want to know if two directions are dependent or not. So I write my H0 and H1. The same as before that we wanted to run a test of hypothesis. After I run my H0 and H1, I need to write my test statistic. In this case, the test statistic is following a chi-square distribution. How do we calculate it? That is Nij, each individual value that you had in each cell, minus expected value of that cell, square that difference divided by expected value of that cell. So the question that you might ask, okay, how can I calculate expected value for each individual cell? As you can see, I can replace it with this formula. Expected value of cell for observation that is in cell ij is ni dot summation of that row times summation of that column divided by total number of observations. The same thing will be replaced in the denominator. Once you have the value of your test statistic, you need to compare it with a critical threshold. What is the critical threshold? It is chi-square of alpha with a degree of freedom of number of rows minus 1 times number of columns minus 1. So, if the value of your test statistic is greater than this threshold, you will reject your H null. When I reject H null, it means I am rejecting the independency. And as a result, I conclude the dependency of two directions.